All right, let's get right into one of the biggest mysteries out there. I mean, we all know that most of the universe is, well, missing. But what if the answer has been hiding in plain sight this whole time, tucked away inside the oldest, darkest objects you can possibly imagine?
Just take a look at this. Everything we see, everything we know, you, me, the stars, entire galaxies, that's only about 5% of everything. A whopping 25% of the universe is something we call dark matter. We can't see it, it doesn't give off light. The only way we know it's there is its gravity. It's like the invisible scaffolding holding our cosmos together. And honestly, we have no clue what it is.
So where do you even start looking for something like that? Well, as it turns out, physicists have had a suspect in mind for a long, long time. One that goes all the way back to the very first moments of the universe itself.
And here it is, the primordial black hole, or PBH for short. Now, these are not your typical everyday black holes. The idea is that these things weren't born from the death of giant stars. Nope, they were forged directly out of the wild, super dense chaos of the universe just a split second after the Big Bang.
And that's really the key difference right here. You've got your stellar black holes on one side. Those are the leftovers of huge stars that went supernova. But then you have primordial black holes. These are the real old-timers, formed before stars were even a thing. And that difference is so important because it means they could have formed in all sorts of sizes, including really, really small ones. Small enough, maybe, to be dark matter.
So for decades, this was a pretty cool idea. But it hit a wall, a huge theoretical wall, actually built by none other than Stephen Hawking. And for a very long time, this problem seemed to totally shut down the case on our primordial suspect.
You see, Hawking's incredible discovery was that black holes aren't really eternal prisons for matter and light. Because of some really weird quantum effects right at their edge, they slowly leak energy back out into space. We call it Hawking radiation. And over incredible amounts of time, this means they lose mass, they shrink, and eventually they should go out with a bang, evaporating in a final, huge flash of energy.
And here's the kicker. The smaller the black hole, the faster this whole process happens. So any of those primordial black holes that were small enough to act as dark matter, well, they should have already fizzled out by now, ending their lives in a violent burst. That explosion would have lit up the cosmos with gamma rays that our telescopes should have been able to see. But we've looked, and we've seen absolutely nothing. For decades, that was it. Case closed.
And at the very heart of this problem was this one theoretical prediction. According to the math, as a black hole's mass gets closer and closer to zero, its temperature, the energy it's radiating away, is supposed to spike to infinity. Now, anytime physicists see infinity pop up in an equation, big alarm bells start ringing. It usually means the theory is missing a piece of the puzzle.
But this is where the story takes a fascinating turn. A new paper is challenging this whole picture by asking a really simple question. What if we've been wrong about what's actually at the center of a black hole?
I mean, the standard model of physics just assumes that every black hole hides something called a singularity, a point of infinite density where our laws of physics just completely break down. But a lot of scientists think that's just a placeholder, right? A gap in our knowledge until we figure out a theory of quantum gravity. So what happens if you just get rid of that idea of a singularity?
And that brings us to this new idea, the non-singular black hole. The theory here is that quantum gravity actually steps in and prevents space-time from being crushed down into an infinitely tiny point. It's like there's a maximum limit to how much you can bend space, and instead of a singularity, you just get this tiny, incredibly dense core. Okay, so have a look at this graph. That line there, the one shooting straight up, that represents the classic singular black hole. As its mass, on the bottom, gets closer to zero, its temperature, on the side, just skyrockets towards infinity. That's the problem we've been stuck with for so long.
But now, watch this. See that second line? That represents this new idea, the non-singular black hole. As it loses mass, its temperature goes up, sure, but then it hits a peak and starts to cool back down again, heading towards zero. There's no infinity. There's no final, violent explosion. The whole problem just disappears. And the result of this is just mind-blowing. Instead of completely vanishing in a flash of light, this new kind of black hole would just cool down. The Hawking radiation would slow to a trickle and then stop, and it would leave behind a tiny, stable, and completely inert remnant. A little microscopic speck of pure mass.
So how big are we talking? Well, the new research crunched the numbers, and they figured that a remnant formed from a black hole at the absolute smallest physical scale possible would weigh in at about 5.7 billionths of a kilogram.
To put that in perspective, that's roughly the mass of a single human eyelash.
And just like that, we're right back where we started, looking at our original mystery. With this incredible new piece of evidence, the case for primordial black holes as dark matter is suddenly blown wide open again.
So let's just recap here. The whole reason we ruled out small black holes was because they shouldn't have exploded, right? But if this new theory is correct, they don't. They just fade away, leaving these tiny, stable remnants. Suddenly, that whole argument is gone. And what are we left with? A huge population of tiny, ancient objects that are dark, have mass, and only interact with the universe through gravity. That sounds an awful lot like a perfect description of dark matter.
And here it is, the final, amazing takeaway from the paper. This new theory suggests that these remnants of primordial black holes, forged in the first moments of time and then stabilized by quantum gravity, could actually account for all of that missing 25% of our universe. All of it.
It's really an incredible thought, isn't it? The solution to one of the biggest puzzles in all of science might not be some bizarre new particle we have to hunt for in giant colliders. It might just be the quiet, stable ashes of the universe's very first black holes, hiding in the dark all along.